welcome. So this is my game. So as you can see, I have a main menu world, and then if I go down to my maps, I have all of these other maps. So I'll go in Desert Throne map A, which is your main map. So as you can see, there's been quite some design put into this map now. So it does have a lot more design. There's enemies all throughout the map, so be cautious. We have our lights in as well. Should go through, and then inside of the building we have these more dim lights. So the dim light is meant to make it seem darker so that you are pretty much forced to use your flashlight. But that is the first world. All of this is blocked off as well with the nav mesh bounds volume. So I brought the nav mesh bounds volume in by going into place actors and then nav mesh bounds volume, and that pretty much just creates a boundary so that if you step outside of that sort of border, then it will take you out of the game. But of course there are a couple little things here and there, like just these needing some slight adjustments. Main menu world test was just a blank map. So if I go inside of the level blueprint, I have event begin play, I have it playing a sound, and then I've created a main menu widget and selected the main menu. I've added it to my viewport. I want to show the mouse cursor and it gets our player's controller. So that is the code for the main menu world test. So this is the starting map where you will start on. And then in test map A, there have been some changes. So originally there's all of this, right? So it started off as just this little area here, which has its own nav mesh bound box, which I'll just move that back on there. But you can see that it is now on, so that makes it darker. This is our other little zone, which I will show soon. But if we go inside of here, so you can see that it's got the player start, which I brought in through place actors. You go through, it's got your lights, you got these rooms, and I actually created these little trigger boxes. So if I open the level blueprint inside of this, the trigger box sets it to teleport to a set location. It gets the player character and it puts that player character in that desired location. So all it is it's beginning the overlap and then teleports, and it gets the player character, and it has the X, Y, and Z location set in stone. So now if we go back to test map B, so test map B is slightly different, more rocky style kind of thing, but you'll start inside of here. Well, whoops, not in here, my bad. You start here. So you start in this little spot here. You've got your pickups there. You'll go through the door, and there's enemies here. We've got our light beams. So all I've done was created a texture, which I'll show soon, to create these light beams, and I've only coded one enemy, and from that enemy I created child blueprints so I could add different skins to make the game feel, well, better. Now, if we go inside of test map C, this is your sandbox world, and yes, it is a literal sandbox. So you start here, there's the pick up there, you've got enemy variant, and another enemy variant, and you've got like all these weird looking shapes around everywhere. So if I go back to main menu world test, I'll go in test map A and go to widgets, and you'll probably notice I have about, BP HUD, Camshake, health system, main menu, options, pause, and world shake. So inside our main menu, I have placed an image. First, I started off by adding a canvas panel, and then in these I've set buttons. So if I go inside of the graph, if you click the play button, it will open the main map, and it will set the input mode game only, set the mouse cursor, and get player controller. So on clicked exit, of course it quits. On click sandbox button does a flip-flop function which actually changes the visibility from hidden to visible, and then if you click it again, it makes them hidden again. Options creates an isValid node, and from isValid we create our options menu widget, where we then promote our return value and we rename it to options menu ref, and we add that to viewport. Now we have that connected in with is not valid, and then is valid is connected to add to viewport, and then we bring back get options menu ref, for example, and put it in input object. Now this is the exact same for on-click test map A, B, and C. So all it pretty much does, it's set to absolute, open level by name, sets input game mode, set show mouse cursor, get player controller, and they are all the same. So now I have my door, right? So these are just the settings with the door. As you can see, we have collision enable, aquarium physics, world static, only pawn can overlap, and yes, character can step up on. All of these are the same, it's visible. Our navbesh bound box is hidden in game, and if I go inside our event graph, so we have created custom events being open door and closed door. So I've created a timeline so that plays open door and reverse closes door, and then in our update we want it to set relative rotation, and I like to set a delay for mine, so I add in a delay, and I have the doors static mesh component point as my target. Target is set in rotation. We have added a lerp in for new rotation Z, and we have created floats being closed position and open position. My closed position is 0 because that's a closed door, and open position is -100, so it opens out to you. So they're connected, closes into A, opens into B, and the alpha is connected into the door track. Now when it finishes, we also created a isOpen boolean. So we have it set isOpen boolean, and we have boolean value not A is open. And with our interact, so as you probably saw earlier, so this is for our interact now. So we set up a sort of starting point, input and output. So for the input we have interact for, goes into branch, condition is not, is open. If it's true, it sets the play rate and opens the door T. So door T was this, and then it opens the door and returns to the node. Now we have a divide plugged into our new rate, and we also have time to open and time to close. So we just set the top value to 1, so it takes 1 second to open, and then we duplicate all the stuff on the top, plug it into false as well, but we actually put time to close in instead, and now that will close our door, and that's connected into our return node, which also has an output of did interact. So now if we go into our options menu, when you click options, go back goes back, main menu goes to the main menu, which I'll show soon. We have all of these settings set in stone as well, and our controls. So in our settings, I'll start right from the top. Resume opens main. So resume main menu, on clicked main menu world test, on clicked resume, remove from parent. Now for the screen resolution, we execute a console command r.set res 720 by 480 for example, and we set it with our different variants. Now for view distance, we go on clicked near, medium and far button. So r.view distance scale 0.4 in our execute console command again, for example. Now with anti-aliasing, so we have on clicked low anti-aliasing button, so we did AA button for short. So we executing console commands again, as you can see, and we have r.postprocess AA quality 0. Now on clicked SQ button, so low SQ button, so executes console commands again to create sg.shadow quality 0. And then in our screen functions, we have it so on screen, on clicked full screen button, it gets the game user settings, the return value connects into set full screen mode as well as in the target. Get game user settings connects into set full screen mode, which connects into apply resolution settings, and we set the full screen mode between full screen windowed and windowed full screen, but all that is the same. And then on click controls button, so is valid. We've created another widget, about widget. We've promoted this to a variable to set the about widget reference. We've added it to our viewport, and we've got our get widget reference into our is valid. So with our pause menu, it is slightly different. So of course, this section is hidden until you click exit. So I'll just quickly show you, but we have a background blur here, and we've added in our text, and we've added in our vertical boxes. So if I open up the graph, on clicked resume button removes from parent, sets the game paused, set input game mode only, plugged into set show mouse cursor, and it gets the player controller. Open close quit box, of course, on clicked another flip-flop function, so it changes the visibility between main menu and desktop. In main menu, on click main menu opens main menu world test, quit to desktop quits, and options function on clicked options, so it will open, it does the exact same function that it did last time. So quick look. So now we also have our world shake. As you can see, we have a 1 oscillation, 0.1 oscillation blend in time, oscillation blend out time 0.2. We have, so there's no rot. Is there lock? So we have some lock set, as you can see. So Y is 0, 0 random sine wave. We have X on 25, 50, 0 sine wave. We have Z on 25, 50 random sine wave, and then FOV oscillation 00 random sine wave, animation shake. Our animation play rate is 1, scale is 1, blend in time is 0.2, blend out time is 0.2. No animation sequence, we don't need to worry about that. So that's our world shake. Now our health system is a blueprint class, so on event begin play it will set the health to 100, our max health being 120, bind event to on take point damage, so it gets the owner, and in the event we've created a custom event on take point damage event, and that will set the shot direction. Shot from direction is connected in, the damage is connected into a subtraction, our health is connected into a greater than, and that's plugged into our branch. So if the condition is true, it sets our health. If condition is false, it calls the dead trigger. So it says you're dead. Now this was our debugger health, so we have our event tick going into a draw debug string. We have our get actor location, so X and Y are plugged into X and Y, and we have broke the link, so we broke that, and Z is connected into addition with the bottom one being 80. We get our target actor component on get owner. Our health is connected into text so that it prints how much health we have. We also have some old code where it will destroy the actor and get owner. So now if I open camshake 1, so we have 0.1, 0.1, 0.2. Rot is 15.3 random Perlin noise, yaw is 15.3 random sine wave, and roll is 15.3 random sine wave. Now our lock is 100, frequency 10 sine wave, and we have 00 random sine wave, 1050 random sine wave, 00 random sine wave, animation play rate 1, we got 1, 0.2, 0.2, and the rest is blank again. If we open up camshake 1, you'll see 0.1, 0.1, 0.1, 00 random sine wave, 00 random sine wave, 00 random sine wave, 25 1 random sine wave, 25 1 random sine wave, 25 1 random sine wave, 00 random sine wave, 1 1 0.2, 0.2, and blank once more. Now if I open up the BP HUD 2, and I'll open up BP HUD 1 as well. So this was sort of the first blueprint HUD. As you can see, we have our health, our sprint, left, right, grenade, and our crosshair. So if I open the graph, it gets the stamina bar %0 return node, and inside that it's connected to the return node, which has a float, so plugged into divide, stamina is plugged into there, max stamina is plugged into there. As you can see, stamina is 100 on the bottom left, max stamina 100. Character reference, which we created earlier on. So in our event construct, we have cast a BP player, we've promoted BP player to character reference, and it sets the character reference, and we get our player character plugged into our object to cast. Now BP HUD 2 has had some changes. We got grenade and gun here, we've got just a random hand for aesthetic, we got our fire rate, and we have health and stamina. So as you can see, we got the little person there. But if we open up this in our event graph, so it sets the opacity for P2 to 0.1, but when we pick up our ammo custom event, which I'll show soon, it becomes 1.0. In our health bar tether, we have BP player, target BP player health system, target health, and max health. So target health is 100, max health is 120, has a divide, connects into our return node. And then our stamina will be getting worked on. So if we look inside our About widget, you can see I've just added settings. We got our main menu and our go back button, which is no difference. On click go back, removes set game pause, set input game mode, set show mouse cursor, get player controller, and on click main menu button, open level by name, get player controller, set input game mode only, show mouse cursor target. So some slight changes. We have our sounds added in here, which I will touch base on. We have our textures, which I will show. They're all the same matte, but different brightnesses. So we have a material expression constant. We have our constant 3 vector, and we have our multiply. So our constant is the color we want of choosing, plugs into A of multiply, which goes into emissive color, and B goes into our value constant. So now if I go to sprites, you can see I've created all of these little images. Now these images are just simple sprites. All you do, you just right click, sprite actions, create sprites from selected texture. We have our game mode, which I created much earlier. So first we got our maps, which we created and have been getting worked on, some map pieces, the image packs that we have used, and now into our game mode. So one should be restarting, but one does not want to restart. However, with the class settings, so game mode base, all of this is standard. In our class default, so game session class is game session, we got game state base, player controller, player state HUD, BP player, spectator pawn, player controller, server stat replicator, and it's pausable. So all of this, there's nothing special about it. That's pretty much it. Now, so let's just go up. As you can see, I've created some more materials. To make like a steel, you just have your constant, a value in metallic, and a value in roughness. And to make your glass, you have your base color, you set your opacity, and we have values of 0 and 0, and it's just made that sort of glass look. Bit hard to see, but you can sort of see it. Now if I go into Daniel, so we got week 2 generated Daniel, and you can see like these lights. So I just created these literally out of simple objects, and then I combine them just to make a light bar. So it's got the steel and light on. And as I make my way higher, so this is that matte that was used for the pillars earlier. As you can see, a constant, a multiply, and a value. We have our characters here. So we have our BP player. So before doing all this, you do need to go inside of your project settings, where you will then go into input, and you set your action maps. As you can see, reload, spacebar, left mouse button E, left control, right mouse button, left shift, escape F, AD, left right, WS, up, down, mouse Y. And mouse X. So we've got our axis mapping and our action mappings, so try not to mix them up. This is all axis, so all of the movement is axis, and then you just save those settings. So we have a damage shaker. On event any damage, we start our legacy camera shake, which I have selected cam shake, and that is connected into get player camera manager. And we have our play world camera shake there. If you push 0, you can print your health, so you can see how much health you have with the BP player health system, which is connected in there. But with our reload, you press R, plays the reload animation, delays, sets bullets to 100, and the duration is divide 2. So we can double click on reload animation, and as you can see, we have it, so it plays our gun reload sound. We then have a sequence which connects into our montage play. The target is get animation instance, and it gets our arms instance, and it plays montage reload, but it also gets our gun instance. So when it plays that, it then plays our gun instance and returns the node, gets animation instance for the SK rifle rather than the arms. And in our event graph, we have laser shooting. So if you select them, you can right click and you can collapse them to functions, nodes, or macros. Functions is generally the way. So if you press it, it sets timer by function name, 0.5 laser shooting. So you have to be descriptive about which one it is. And when released, it will clear the timer by function name. So I'll quickly show laser shooting. It compares the int. The input is your bullets, which is an integer that we made earlier. So bullets will be right there. So bullets is there. And it compares the integer. If it's greater than, then it minus minuses. But if it's equal, then it will print the string, or if it's less than, it prints the string. But anyways, the less than, it calculates the amount of bullets, so it takes one after every shot, and it will play the sound right after gunshot sound, and it prints the string to tell you how much, which connects into our start legacy camera shake. So we have our cam shake in there again. As you can see, scale is at 1. Get player camera manager. So if I just browse, so it is cam shake 1 that I've used. Goes into montage play. The target is get animation instant. Target is skeleton mesh component, SK custom arms. It plays our montage shoot. It connects into line trace by channel. So the start gets the world location and the gun hole, and the end it is a vector addition, the top one being get world location into camera, and the bottom one is times, so multiplication, vector multiplied by a float. So we've plugged in our range being 1000, and that is connected on the top into our random unit vector in cone in degrees. So as you can see, adding multiplication, multiplying variables, distance, randomizing, and the inaccuracy is how much it goes off. So that's another one we made. We set it for 3, so that it's only like a small spray, and that connects into cone half angle in degrees. Now that's so the cone direction is connected into get forward vector, which is connected into our camera as well. But you'll probably see we have trace channel visibility, draw debug type none, ignore self, trace color black, trace hit color green, draw time 1. So it creates a sequence right off the bat, which goes into activate. P rifle shell eject is our target. P rifle muzzle flash activates right after, which is our target. And after that, it will spawn our decal, which has a random float in range between 10 and 20. The location is hooked up into our out hit impact point. Decal size is hooked into random float in range. And our rotation X is hooked into random float in range. Rotation Y is hooked into rotation from X vector. And rotation Z is hooked into return value Z yaw, which is hooked into rotation from X vector, which connects into out hit normal. We've got our min into our X as well, between rotation from X and random float in range. Our lifespan is connected into a timer of 6. That's for the decal, and as it continues on, it spawns 2 emitters at location, so the emitters are just connected into each other. Places the emitter, 0.25 scale, it'll auto destroy after a set time, and as you can see, the location is hooked up into out hit location. Now, as you can see, we have a then, so then it connects into a branch. So if it's not true, and if it hits an enemy instead, then the condition connects into our return value in our line trace by channel. Our out hit actor connects into the cast to enemy divid, which as you can see is connected into our branch. And we have hit from direction connected into out hit normal. It, as enemy divid, it damages actor, and cast to enemy divid is connected into apply point damage, base damage being 10. So that is the reload there. Now, left and right, of course. Left and right, input access hori, adds movement. World direction connects into get actor right vector. Access values connected into multiply. That's set to 1. We have an is sprinting function, which I'll show soon. So we also have forward, which is input access 30. So we actually set the settings inside of the project settings. So we'll set them to -1, +1. It sort of depends on the value on which direction you're going. But as you can see, we have our left and right, forward, and these are the things we have. So in start sprinting, if we double click on that, max walk speed 600, character movement is our target. It sets is sprinting on, and it will drain our stamina. In stop sprinting, character movement, max walk speed 250, is sprinting is off, and it allows us to regen stamina. Back to the event graph. So we have left and right look, add controller your input, so that's 1 access value connected into mouse X, and mouse Y is -1 with multiplication. Looking up and down, it's the exact same minus that, so it just doesn't have that. That's the only difference. We have jumping, double jumping. So in jumping, double jumping, input action, then jump. So jump, target is character, stop jumping, target is character. Right? So if I go to BP player on the right, you can see users and animation blueprint. We have our advanced settings. All of this is set, range 1000, inaccuracy 3, timer 6. But you can also just search, so you just go jump. So max jump apex attempt per simulation. I have mine set to 2. You set the velocity, air control boost multiplier, air control boost velocity thruster, falling lateral friction. So we've got our impacts, apply gravity while jumping, can jump. But with our, so across this, with our collision collider, dynamic obstacle, nav area obstacle, we have all of these settings, visible, hidden in game, right? All the things you think it would be. So, can character step up on? No. Collision preset pawn. And if we, so BP play yourself, so if we go down to our collision setting, hidden in game, capture component, you've got to have it set to can jump as well. So mesh character mesh. So can character step up on owner. Collision preset is character mesh. So pawn, ignores vehicle, and ignores visibility. We go down to SK custom arms, I think it is. Okay, so collision, can character step up on, owner, no collision, collision presets set, SK rifle, no collision, but with our spotlight, we add the spotlight. I'll show you in the viewport. We added it to our little gun hole. So you adjust all of this. Whoops. So you adjust all the intensity. You choose your light color. You can set the radius. But I'm just going to keep mine to about 1000. You can set the outer cone. You can set the inner cone. As you can see, doing so stretches the outer cone. You can set your source radius as well. And you pretty much make it so that it is visible, because you want the light to be visible. So in our visibility, which I will show, so it's not visible. It's ticked off because we don't want it visible at the moment. But in our event graph, so where are we up to? Oh yes, so sprinting function, so shift to sprint, pause, unpause, input action, pause screen is valid, connecting to pause menu reference, which we get later. So there is valid, connecting to a branch. If it's true, removes from parent, sets game paused, set input game mode, connected in with our get player controller, target, get player controller, and our pause menu ref is connected into our remove from parent, our in widget to focus, and our add to viewport for the false setting. So we have is game paused plugged into the condition. We promoted our pause menu widget to a variable earlier, so just to make that a bit easier to see. So if it's not valid, it creates pause menu widget. That's how we got our pause menu reference earlier to connect into our branch. So if we continue on with this, don't need to worry about the escape button, because that's not important with this. So as you can see, adds to viewport if it's false. and sets game paused is ticked, show mouse cursor is ticked, and it's plugged into set input mode game and UI. So we have it to lock in full screen, and we have to make sure all of that is plugged in. With the sighting, press, place the montage, get animation instant is the target, SK custom arms. What else? Oh, if you press 0, it will print the health string. Sorry if I already went over that. Up here we have interact. So E is our interact key. It'll play a door lock sound. So it'll create each loop with break. And the array is connected into get overlapping actors. Now we have it looping the body into the branch. So the array elements is connected into does implement interface, which its boolean is connected into our branch's condition, right? So array elements also connected into interact, which is connected into true of the branch. It interacts for get reference to self, and that interaction branches did interact condition goes connected in, and it comes all the way back around to break. Now in our flashlight, we just toggle the flashlight, pressed A, play sound light switch 1, and it sets the visibility, yes, and it propagates the children. Spotlight is connected into target, and if B, then it plays light switch 2, sets the visibility back off, and turns on spotlight target. Now the next thing is drain stamina. So we've created a custom event that we've called drain stamina, which connects into set stamina, and we've added a clamp integer. Now the value is connected into a subtraction, and the top one is connected into our stamina being 100 and the bottom being 1, so it takes away 1 every time you're using it, and the max stamina is connected into the max value in clamp integer. Now after set, it connects into our branch, and the branch's condition is connected into a equal equal. So the top value is connected into the bottom of our right side of our set stamina, and the bottom is just 0. So if the branch is true, you stop sprinting, of course. If the branch is false, it branches again. So branch is false condition is sprinting, and it creates a delay of 0.1 seconds, which drains your stamina. So over here we have regen stamina, as you can see, which is another custom event. So it's literally the exact same, except instead of a subtraction you have an addition. You still have the equal equals, but there's no true, and the false is connected in, so it has false false delay of 0.05 seconds, and then you start regenerating stamina. So that is, oh, and over here we have our HUD. So on event receive restarted, it creates our BP HUD2 widget. It gets our player controller. The BP player is self, and we've promoted these to variables that we've called the HUD. So we set the HUD, and we add the HUD to our viewport. It's connected in. We set the camera fade. Target is get player camera manager. We set our bullets 100. Now the ammo pickup, it's just a custom event, toggles the ammo, the HUD. So if we double click that, you can see in our BP HUD2, toggle ammo sets opacity P2. So that's it for that. Now, if I continue on, where am I at now? Ah yes, so we have enemy divid, right? So it prints our string. Now, this one's a bit more hectic. So in our event tick, it creates a branch, which we've created an event called triggered. We have max health and health in here. So we'll just set that to 120 in this as well. Oh, wait, let's make it 100. Make it even with the health and max health. So we're only using health at the moment. We have a triggered boolean, a retreat radius boolean at 100, and a target being the AI controller. So if it's true, then it compares the float. The input being get distance to the player compares with 1300. If it's greater than, the AI will move to an acceptance radius of 5. The reference is self and it gets the player pawn. So it will do this once. And it will clear the timer by function name after it does it once. And then if it's less than, so it sets the actor rotation. We have find look rotation to player, which we created. So we collapsed a macro. So it gets the actor location, goes into find lookout rotation, goes into start. The target is get actor location, which is get player pawn. The Z is plugged into our B on lerp, and our A is plugged into our Z on lerp, with the alpha being 0.08, and the output is angle to player, and we didn't really need to worry about input for this one. So if I go back to the event graph, so now you're understanding that we have macros. So this get distance to player, the reason why it's collapsed to macro is it makes it cleaner. So we just created a float that we call distance to player. So it gets actor location, the distance vector of V1 plugs into actor location, V2 plugs into actor location as well, but the target is get player pawn, and the return value plugs into our output. So we don't need to worry about our debug sphere because that's not important right now. But you can see that that is the get distance to player. So now it will stop active movement after it gets the set actor rotation and the character movement. So that's character movement there. So it will do it once and the reset goes into clear timer by function name, and after completed it sets timer by function name, time being 0.5. Now this is what the debugger looks like, just something very simple. Has the get distance again, but we created a dead trigger for our health system. So set simulate physics, target is SK Battle Drone 1, it simulates. After it simulates, it adds the impulse on the SK Battle Drone 1, the impulse being times 3000 in our vector times vector, and it is shot from direction to the BD health system. After add impulse, it has a delay of 3 seconds before it then destroys the actor and spawns lightning. So it will get the actor's location and the rotation. Now, in our false condition for our branch on our event tick, it compares the float with 1000. So 1000 rather than 1300, it gets distance to player and sets the triggered. On event begin play, enemy will fall back. Now, how the fallback works, it's a custom event that we created. It draws the debug sphere, centers the retreat point at 1000. The radius is our retreat radius, which was a float we made earlier. Our retreat point is the origin. Retreat radius goes into radius. And our debug sphere is connected into get random location in navigable radius, which connects into AI move to, and the pawn is self, destination, random location, but the location is connected in earlier with our retreat distance. And that is pretty much it. With the retreat distance, it's another macro that's been collapsed. So input distance, output retreat point, connects into times by times, gets actor forward vector, that's back as it goes forward. It's addition, which connects into get actor location being plugged in the top, and then the end of that plugs into our output retreat radius point. And with shooting, when he's shooting at you, so I'll just is it going to okay, so shooting spawns actor bullet 2 and the spawn transform gets world transformed from the gun hole. So the enemy would just be shooting. And with the child blueprints, all I did, I right clicked and create child blueprint class, and what that does is it replicates all of the code in it the same, so you can just click on it and you can just change the material or the skeletal mesh asset, but they all have the same code. So you do not need to worry about that. So all of this, the event begin play is just plugged into parent begin play because it is a parent. Construction script is plugged into parent construction script. The viewport is the exact same. Health 100, max health 120. So they're all connected into the same health system. But now to show you how the game actually runs with everything in, and I will explain as I go along. When I find maps, there we are. So how I start, I open main menu world test. And so let's just go standalone game. And now I will run that. One moment, just waiting on it to load. So I'll just alt tab that. And let's go window. So 1920 by 1080. So you can hear it's got the soundtrack now. This is how our UI works because we just set the colors and everything. Play, sandbox, options, and exit. Sandbox, we have 3 options. We click it again, it's gone. It's there, it's gone. It's there, it's gone. We open options, and all it's doing is deleting the widget as explained earlier. We have all of our controls in here in clear point is you're able to access it in-game, which I will demonstrate. So inside of play game at the moment, he just keeps shooting. He's running, he's got his double jump. The health will need to be, I mean not the health, the stamina will need to be keyed back in. But I'll show you one of the lightning. So just very simple code, but we have a light here. So that's one of the lights I showed earlier. And as we keep going through, making my way downtown, walking fast, faces fast, and I'm homebound. So we've set the dimmer lights in here. We've got our flash, so we can see a bit better. So it tells you when to reload as well. So there will need to be a set, because at the moment you do not. You will need, which will be getting set, so all the bodies fade away. But if we exit back to our main menu, we'll go into our sandbox. So the sandbox of sandbox, it is a literal sandbox, one of the easiest things. So on the bottom right, that's our UI working. Boom. And you can see the health going down. So as I'm right clicking, you can see it's not really doing much, but that's because it's bugging at the moment. But these blocks will need to be filled in, which they will be, but then again, this is a sandbox, so there's allowed to be grey boxing. So it's got all the animations set in stone. He's all set. He's good. Right? So we go back to main menu, sandbox, choices. I really should be switching around the names for this. So you pick up. And the door sometimes, that's okay because it doesn't glitch there. So there may need to be, so there's still of course a lot of adjustments that need to be done. Is there someone else in there? Nope, I'm just tripping out. See, so it doesn't keep shooting, it just says reload. And then you reload. But I do want the number count to be in properly, but this is one of the areas. It's just a basic big open world area. We go back to our main menu. If you want to see me properly go through these, then you'll check out my other videos. So this is your base spawn area, as you can see. Also the numbers will be gone. So big light here, we got our first teleporter. So very flashy colors. This one's a lot darker, so it's a bit better to see the light. So it's a bit of a dark area, but this makes it a bit better to just look through. It gives you an excuse to have to. So if we go back to our main menu, because I haven't set a backtracking point yet, but if we go to the left this time, so a whole new area. So of course there's a lot of things that need to be adjusted, but you'll work it out. But as you can see, that is the brief for everything.